Today we are going to be solving some multi-step inequalities. And let's take a look at our first problem here. So notice we've got this fraction bar. To undo the fraction bar, we're going to multiply by the denominator in this case. So when I do that, here I'm left, when I multiply by -2, I cancel out those denominators. Now careful on this because we have an inequality. We've left with x plus 5, but notice that it was x plus 5 over -2 was greater than 3, but then once I multiply by a negative, the sign is going to end up switching around. And so from this point, I end up only having to subtract the 5 from all sides. Notice how they're the same sign, so I end up adding. So my answer is x is less than -11. So -11, I'll put -11 in the center, 0 be off to the right, less than means open circle, less means to the left, and that would be what we have. Let's take a look at our next one. Same sort of thing. We're going to multiply by 3. Now this time I'm multiplying by a positive, so the inequality sign is going to stay the same direction. 1 minus 2n is greater than or equal to 21. And so from this point, I can subtract that 1 from all sides. That leaves me with this -2n is greater than or equal to 20. So now I'm dividing by a -2. But when I'm dividing by a negative, this is where the sign switches, because before this was greater than or equal to when it was a -2, but now there's no negative sign there, so that means that we're going to switch the inequality sign. So n is less than or equal to -10. So 0 is off to the right from -10, closed circle, less means to the left. Taking a look at our next one here, we're going to distribute the 2 over the x plus 4. Don't add, because in order of operation we multiply before we add. So what we're left with is 3 plus 2x plus 8. This is greater than 3. So now I'm collecting some like terms. So I'm going to collect the 3 and the 8. I can do this by using that commutative property, moving the 8 next to the 3. And so what I'm left with is 11 plus 2x is greater than 3. So now I'm going to use opposite operations. So I'm going to subtract that 11 from the 3 and from the 11 itself, leaving me with 2x by itself is now greater than -8. Now notice this time I'm dividing by a positive. So when you divide by a positive, that inequality sign stays the same direction because I'm not changing the sign's value on the left-hand side. So x is greater than -4. So it doesn't matter whether the constant's negative, it's only the variable term that makes the difference. So -4 goes in the center. Again, 0 is off to the right. Open circle, and x is greater than means to the right. Next one, I'm going to get rid of these fractions. I'm going to multiply every number by 8 to eliminate the fractions. So here the 8's cancel, so it leaves me with 5 is less than. Here the 8's cancel. I've got 3x. Here 4 goes into 8 2 times. You multiply these two numbers, you get -2. So now I'm ready to solve. I'm going to just do some opposite operations. I'm adding 2 to both sides. So this leaves me with this 7 is less than 3x. And then I can go ahead and divide both sides by 3. And we end up with an improper fraction, and that's okay. 7/3 is the answer. Is less than x. Now if you want to write it the other way, which is the way you'd see it on a multiple choice test, so it's best to understand which way they go. Notice how x is open, the inequality sign is open to the x, so I need to make sure it's open if I have it the other way around. And so if you ever move the variable to the other side, it ends up switching that inequality sign. 7/3 goes in the center. This time 0 is on the left because 7/3 is positive. Open circle, and x is greater means to the right. Next one here, I could go ahead and simplify on the right-hand side, so I think I'll do that. I could distribute as well, but I'm actually going to get rid of this fraction. That way I don't have to deal with the fraction. So I'm going to leave it there for now and just simplify the work on the right-hand side. And so I have to change that to a 16. I have to take that 4 and square it first, then subtract. So I've got -10 now. And now I'm going to go ahead and multiply by the 4. And what that does is it allows it so I don't have the fractions involved inside the, where I had the numbers inside the parentheses to start with. So I'm going to go ahead and multiply both sides by 4. On the left side, just the 1/4, because the 1/4 is being multiplied by this difference. And so just multiplying by the 1/4, since it's a factor, is all I need to do. So that now leaves me with just the x minus 10 greater than or equal to negative 40. So all I have is just one step at that stage, and all I'm going to do is add the 10 to both sides. So it's opposite sign, so I subtract. X is greater than or equal to negative 30. So if I was to put that in the center, negative 30 would go there. 0's off to the right. It's a closed circle this time. Values of x are greater than, so off to the right are the answers. Well, I've got a couple word problems associated with some inequalities. Let's read this one. It says a sales representative is given a choice of 2 different paycheck plans. So one choice includes a monthly base pay. Base pay means this is like you're always going to get it. This is your constant, something that's always there. And so we've got 300, so we'll call this plan 1 here. Plan 1, so $300 plus, so I say plus 10% of the sales. So 10%, I'm going to write that as a decimal. So 0.1. So 0.1 times the number of sales. So I'll use an S for sales. Alright, so that's the amount for plan 1. Now the second plan, second choice, so plan 2 we'll call it, the monthly salary is $1,200. This is just, a salary is just a constant amount, so it doesn't change. And so that's what you're going to end up having, so $1,200. And so what they're saying is, for what amount of sales, so there's our unknown, the amount of sales, would the representative make more money with the first plan? More money means that we want to use an inequality sign. So notice that we want plan number 1, the first plan, to be greater than, more than. So now we're ready to solve. So what we'll do is we'll subtract that 300 from both sides. So I'm going to subtract the 300 from the left, subtract it from the right, and now I've got this. I'm going to rewrite this as 0.1s equals, and this makes 900 when I did that subtraction there. So all I have to do now is divide by 1/10. Now when you divide by 1/10, the numbers are not going to change, it's just the decimal point. So move the decimal point over one space. Here I'm going to just add a 0, and there's my answer. S, the sales, equals 9,000. So $9,000 in order to make it so that plan 1 is the better deal. Here it says one cell phone company offers a plan that costs $29.99 and includes unlimited night and weekend minutes. Another plan, so this is a constant. You're always going to pay it. So it's a constant. It's not changing. So let's call that plan 1, just like we did on the last one. $29.99. Alright, so then we read on, it says another company offers a plan that costs $19.99 and charges 35 cents per minute. See the word per? This is a variable now. So it's a variable amount. It's a changing amount. This is a constant because you're going to pay that $19.99 each time. So we have $19.99 plus the variable amount. So 0.35 times the number of minutes. So we'll call that M. So this is plan number 2. So it says, for what number of night and weekend minutes does the second plan, so this plan here, cost more? So cost more than. So we're going to go ahead and draw this inequality sign this direction because it needs to be more than plan number 1. When will it be greater? See, it's open to plan number 2. So that's what we're going to end up doing. So again, more than the first. More than the first, so that means that's why it was open to plan number 2. So we go ahead and solve this just like we had done before. We're subtracting that $19.99 from both sides. And the nice thing about this problem is that the cents cancels out, so here we're left with 10 is less than 0.35 m. So I'm dividing by 35 hundredths on both sides. So remember, just as we had done before, we end up having to move that decimal point. So we go ahead and move that decimal point over 1, 2 spaces, and add 2 zeros. And now we're just doing 35 into 1,000. So we'll start with 35 into 100, and that goes 2 times. Not quite 3, but 2 does, and so that ends up giving me 70. Do the subtraction, I got 30 left over. So now I'm thinking of 35 into 300. So if a quick way to do it is cover up the 5, cover up the 0. 3 into 30 goes 10 times, so I'm going to try about 29. And so I do the math there, that makes 45. And this makes 27 plus 4 gives me 31. So it's a little over, so it'd have to be about 29 or 28. So it's going to be a little bit more than 28. So we'll say 28 minutes. It's more than that one, so we'll go with about 29. About, this stands for about here, about 29 minutes. We'll just round it up. So that's our answer for the last one. Those are the problems that you'll see on tonight's homework or similar problems. Good luck.